Good morning. So let me see what are the things that what we have seen in class. Last class, actually, we have seen about what about the signals. Okay, how we can represent the signals. What are the types of what are the elements? Okay, so everything that we have seen in the last class. So actually, these are all about to have a review about our signal and system. Okay, so today we are going to say about a review about our system. When you are saying about system, the classifications can be of different types. The first classification, what we'll be saying of now, system is to be named as a static and dynamic system. So what is static and dynamic? So when a discrete time system is called a static, or it can be otherwise named as a memoryless system when the output depends on the input samples at the same time. It is the output should be depending only on the present input. It should not depend on past or future. Okay. So the output at any instant depends on the input at that instant. That is to be named as a static system. Uh, so only the present thing alone can be used over here. So that is why we'll be naming it is to be named as a memoryless system. Okay. Example, see over that y of n is equivalent to a into x of n. So which indicates the present input value. That is the input at that instant value. That is to be named as a static system. Next, we are going to see about an dynamic system. What your dynamic system says, as a system is said to be dynamic or obviously opposite of your static. So it should have a memory. So if you're having a memory, the output should depend on past or future samples of the input. Okay, that is the output depends on past values of input. So what will happen when we are refining your past? We should have some memory. So that is to be named as one memory system. So example, y of n is equivalent to x of n minus 1 past value. We have x of n plus 2, 2. So which will be indicating about the future value. So this is about the first classification, static and dynamic. Hope I think so it will be clear. The next will be defining about an causal and non-causal. So the system is said to be as a causal system when the output depends only on present and past input. It is present and x of n. Past means x of n minus 1. Okay. It should not depend on future input. It is x of n plus 1, x of n plus 2. Okay. That is to be named as a causal system. So if we are defining system to be a non-causal, obviously it will be depends on the future system, future inputs, or the non-causal can be otherwise named as an anticipatory system. Okay. So for example, see over there, the y of n is equivalent to x of n plus x of n minus 1 indicates system to be an causal system, whereas y of n is equivalent to x of 2n will be indicating about its non-causal system. Okay. So static and dynamic was over. The next classification says about an causal and non-causal. Third one, we'll be saying about an linear and non-linear system. So when we are defining this, we have to remember the principle, superposition principle. So a linear system is the one which satisfies the superposition principle. The principle states that the response of the system to a weighted sum of signals is be equal to the corresponding weighted sum of the output of the system to each of the individual input signals. Okay, so that is to be named as a linear system. So the linear system which will be defined as the which has to satisfy the superposition principle. So the superposition principle, which is given as the expression, that is the transfer function of a1 into x1 of n plus a2 into x2 of n. So that is the response of the system to a weighted sum of signals should be equivalent to the corresponding weighted sum of the output of a system to each of the individual input signals. So that is the t and a1 will be given of with respect to each individual input signal. So a1 into t of x1 of n plus a2 into t of x2 of n. Okay, where x1 of n and x2 of n, a1 of n and a2 of n are to be the arbitrary constant. So for example, y of n is equivalent to n into x of n. So if it does not satisfy the superposition principle, then we are saying that is to be a non-linear system. So y of n is equivalent to a into x of n plus b. Okay. And the next one we have to define what is time variant and time invariant system. So when you are defining a time variant and time invariant, actually if and only if it should satisfy the equation x of n. So x of n to be y of n. It is for every input signal x of n, that should be every time shift k. Okay. So in other words, when you are defining a system to be a time invariant system or shift invariant, if the characteristic of the system is do not changes with time, not changes with time. So for example, this y of n comma k, that will be equivalent to y of n minus k. Example, we'll go for a differentiator. Okay. Similarly, when you are defining a shift variant, this time variant system, the system is said to be time variant or shift variant if the characteristic of the system changes with time. That is y of n comma k is equivalent to y of n minus k. Okay. And final expression, we'll be saying about that stability and unstable system. We know the condition of an BIBO, there is to be a bounded input and bounded output stable. So when this is repeated 2 mark 1, what is defined BIBO stability? An arbitrary relaxed system is said to be bounded input, bounded output stable if and only if every bounded input produces a bounded output. So summation n is equivalent to minus infinity infinity, h of n should be less than or equivalent to infinity. So unstable system for bounded input sequence x of n, the output is unbounded. The system is classified as an unstable. So for all the classifications, static and dynamic, linear and non-linear, time variant and time invariant, and the last one to be a stable or unstable. Okay. So let me see some examples, and apart from the final, one more thing, partial and non-partial. So we are seeing 5 different classifications. So based on that, we will be working out some problems to find out all systems are to be the given factor. So let me first one, we will be find whether the following systems are the static or dynamic. Or to tell you that what is static? Static is to be the memoryless system. It depends only on the present input value. Dynamic will be depending on past and future. So by seeing a first expression, you can say that what is x of n minus n, x of n minus n, past input. System is to be a dynamic. And y of n is equivalent to x squared of n, x of n. Okay. X squared, don't consider this to be the future value. It is just the input is to be squared. Okay. So it depends only on the present input value. So what you can say that system is to be a static one. Okay. Same, what will happen? Y of n is equivalent to x of 2n. X of 2n indicates present input, past input, or your future input, future input. So the given system is to be a dynamic. Y of n is equivalent to x squared of n. It depends upon your present input. So it will be given as a static. Okay. Next, let me say about if the given system is to be a causal or non-causal. So what is the output of a sequence? Y of n is equivalent to x of n plus 1 by x of n minus 1. So you replace n is equivalent to minus 1. What will happen? X of minus 1 plus x of minus 1. N is equal to 0, x of 0 plus x of minus 1. For n is equivalent to 1, x of 1 plus 1 by x of 0. All the values which depends on present and the past input. So right or not? Okay. So system is said to be a causal one. Non-causal, it has to be depends on future. Okay. Y of n is equivalent to x of n squared. So when you're replacing minus 1, it will be 1. If you are replacing 0, the value will be 0. If you are replacing 2, 1 will be 1. Okay. So if we are replacing 2, it will be replacing 4. So for all the values of A, the output depends on future input. So system is said to be as a non-causal. Okay. Similarly, C, can you say me Y of n is equivalent to A into x of n plus B. So which depends on present, past or future. Good. It depends only on the present and past. So we'll be saying system is to be named as an causal. Similarly, the next expression, so there is no any future input. So we'll be saying this is also to be as an causal one. The next we have to see given expression is to be a linear or non-linear. Linear or non-linear. So what is the given expression? What principles it has to obey over on it? It has to be obey on the superposition principle. So y of n is equivalent to x of n plus 1 by x of n minus 1. So we'll be having of an x1 of n and x2 of n or to be the corresponding output. So you replace p into x1 of n. So x1 of n plus 1 by x1 of minus n. Similarly, t of x2 of n is equivalent to x2 of n plus 1 by x2 of n minus 1. So the output due to weighted sum of input is, so you make over there a1 into x1 of n plus 1 by a1 x1 of n minus 1 plus a2 into x2 of n plus 1 by of a2 of x2 of n minus 1. Okay, so this linear combination of two outputs. So let's see here equation 3 and equation 4. So a1 x1 of n plus a1 by x1 of n minus 1 because we have to multiply with a1 with y1 of n. Okay, so we'll be getting, so when you're comparing the equations 3 and 4, it does not obey the superposition principle. So the system is not non-linear. Is it clear? So the next is, suppose if we are considering y of n is equivalent to n into x of n. So what will be getting over on it? So you replace n into x1 of n into x2 of n. So you will be doing of an a1 into n into x1 of n plus a2 into n into x2 of n. So now you have a linear combination of two outputs is a1 into y1 of n plus a2 into y2 of n. So now you make a comparison of the equation 3 and 4. So what will happen? The 3 and 4 equations are to be the equal. So we can able to have here system is to be as a linear system. Okay. So you can try out for the given problem y of n is equivalent to 2x of n plus 1 by x of n minus n and y of n is equivalent to n into x squared of n and then y of n is equivalent to x squared of n in order to find the system to be a linear or non-linear system. Okay, the next we are going to find out the system is to be the time invariant or time variant. So what is y of n? Y of n is equivalent to x of n plus x of n minus 1. So we'll have to delay by k units. So where and all we'll be having the expression y of n comma k is equivalent to x of n minus k plus x of n minus k minus 1. So if the output is delayed by k units in time, then we'll be having that y of n minus k is equivalent to x of n minus k plus x of n minus k plus 1. Okay, so both or all the value, both the equations are same. So system is to be time invariant. Okay, the next one we'll be having of an y of n is equivalent to x of minus n. So you'll be replacing x of minus n minus k. If you are delayed by the unit, x of minus n plus k will taken over on it. When you're comparing these two equations, so obviously both are to be the time variant value. Okay, actually it is not equivalent. So we can able to conclude that the given system is to be time variant. Okay. The next we have to determine. So by giving some examples, x so y of n is equivalent to x of n by 2, and the next one y of n is equivalent to n into x squared of n. Okay. Last problem we are in need to know. We are going to find that is we are going to test the stability of a system which of n is equivalent to 1 by 2 whole to the power of n q of n. Okay, so we know the what is the stability condition? Summation n is equivalent to minus infinity 1 by 2 to the whole power of n will be equivalent to 1 plus 1 by 2 plus 1 by 4 up to till it goes to infinity. So we know the geometric expression of 1 plus is 1 plus a squared up to infinity can be given as 1 by 1 minus a. So 1 by 1 minus 2 will be getting off into which is less than infinite value. So what you can able to conclude, the given system is to be stable. Okay, and the next problem y of n is equivalent to x of n into u of n. So when it is bounded, it should be less than or equivalent to m. So the given system is to be stable. The next one, y of n is equivalent to x of n plus n into x of n plus 1. So x of n is bounded, it should be less than or equivalent to m. Then we will be having over on it y of n is equivalent to x of n plus x of n plus 1. So when you are seeing over on it, so it is not under the bounded input and bounded output value. So we can able to conclude that the given system is to be a unstable one. Okay. So far what we have seen over on it. So we have seen about what about the classifications of systems and what are all the how we can understand by giving some example problems, and apart from that, some homework problems has been given over on it. So complete it, and we can see on tomorrow. Thank you.